Welcome to our tutorial on converting to sheet metal. In SolidWorks 2009, you can convert solids or surface bodies into sheet metal parts using the Convert to Sheet Metal command. Let's begin by selecting Insert from the main menu, Sheet Metal, Convert to Sheet Metal. Now let's select our fixed entity first. We specify the thickness, as well as the bend radius here. We're also able to reverse the thickness if we like. Next, we need to select the bend edges. The first edge we select has to be next to the fixed edge entity. If I select just some random edge, I'm going to get a warning message about it. Let's select our second bend and the third bend. SolidWorks automatically selects the ribbed edge. Here's another one. Last one here. As you can see, the ribbed edge was selected automatically. We're able to change individual bend radii by entering a numeric value in the callout boxes. Down below here, we have the option to select rip sketches. Set the gap here and specify auto relief. Let's click OK. Now we're going to flatten our part. We get a warning message. The part contains features that can't be unbent. Let's close the warning box. My thought is that we probably just need to change the bend radius. Let's check it out. Let's go ahead and increase the bend radius. I'm going to try a value of 3 millimeters instead. Click OK. Right-click and unsuppress. And now it works fine. And this concludes our tutorial about converting to sheet metal. Welcome to our tutorial about cross brakes. You can add cross brakes to sheet metal parts such as ducts to stiffen, reflect water, and so on. Let's begin by going to the Insert command on the main menu, select Sheet Metal, and Cross Brake. First, we select the face to which we'll add the cross brake. Let's click here to reverse the direction. We can change the brake radius as well, and the brake angle. We can also edit the cross profile. The corner of the cross has to be at the end of the edge. Keep that in mind. And let's click Finish. Here we can adjust the sketch a little further if we need to. And let's exit our sketch. The cross brake is basically a graphical representation. It's not a geometrical entity. When you create a drawing from a cross brake part, the flattened view is labeled with the bend direction, the bend radius, as well as the bend angle. This concludes our tutorial about cross brakes in SolidWorks 2009. Welcome to our tutorial about weldment groups. In SolidWorks 2009, we're able to define weldment groups. A weldment group is a collection of related segments in a structural member. Weldment groups can come in two types, contiguous and parallel. A contiguous group of segments is joined end to end. A parallel group of segments is basically a discontinuous collection of parallel segments. First, let's right-click and bring up the Weldment's toolbar. I'm going to select Structural Member. Let's choose the ISO standard, a C channel type, and 80 by 8 in size. Now we start to define the groups. The second member I select is what defines the group type, contiguous in this case. After I finish my first group, I click New Group to create a second group. Now we'll do a parallel group. Okay, new group again. Group number 3 will also be a parallel group. And let's do another group. Group number 4 will be a contiguous group. After we define the group, we can work with it as a single entity without affecting any other structural members. Let's select group 3. And let's check mirror profile. Now let's select group number 1. We'll scroll down the control interface. Let's select an end miter control treatment. The gap between the corner will be 10 millimeters. Tab. Now let's zoom in on one of the corners. We can opt to set corner-specific weld gaps by checking this box. Let's make this one 5 millimeters. Tab. And OK. The rest of the corners, as you can see, aren't affected. Let's click OK. This concludes our tutorial about weldment groups. Welcome to our tutorial about the Trim and Extend tool. The Trim and Extend tool splits structural members that are crossed by another structural member. You can also opt for a weld gap between structural members and then keep or discard the split side or extend the structure. We're going to begin by activating the Trim Extend tool. Let's pin it down. First, we select the body to trim. Now we'll select a trimming boundary. We can check here to allow for a weld gap. Let's enter a value for it of 10 millimeters. Here we have the option to keep or discard the trimming side. You click on the callout to toggle in between the two. Let's click OK. Now I'm going to select this structural member. Let's ensure that Allow Extension is checked. Let's select our trimming boundary now. I'm going to select this structural member and click OK. Now let's cancel out. This concludes our tutorial about the Trim Extend tool. Welcome to our tutorial about the Gusset tool. In SolidWorks 2009, we can now create gussets using chamfers. This allows room for a weld bit under the gusset. First, I'll activate the Gusset tool. Let's select the supporting faces first. Now we'll enter numeric dimensions for the profile. 150 millimeters for distance 1 by 150. Tab. Let's select the midpoint location. Here we've got a new feature, the chamfer. Let's enter a value of 25 millimeters here by 45 degrees. Tab. If we scroll down below, we see that the parameters section is now called Location. I'm going to click OK. And this concludes our tutorial about the Gusset tool. Welcome to our tutorial about the Endcap tool. In SolidWorks 2009, you can simultaneously add multiple caps to multiple faces. Let's begin by activating the Endcap tool. I'm going to select this face and this face. We now have the option to project the cap inward, as well as keeping the original length of the structure. The Use Thickness Ratio and Chamfer Corner options work just as they did in previous versions of SolidWorks. This concludes our tutorial about enhancements to the Endcap tool. Welcome to our tutorial about the Bill of Materials in assembly files. In SolidWorks 2009, you can now create the Bill of Materials directly within the assembly file. Go to Insert, Tables, Bill of Materials. You can specify all the properties on the Bill of Materials within this property manager, and then click OK. You can insert the bill of materials into any desired position. The BOM appears in the Tables folder in the Feature Manager design tree. Let's right-click on it. Show Table in New Window. Here's a separate window. We can edit the bill of materials here, or we can edit it in the main window. To edit it, simply click on the cell that you want to change. The formatting toolbar contains a number of familiar options. When you're finished editing, click on an empty area in the new window. We also have the option to change part names from the bill of materials. Double-click on the part name. SolidWorks prompts us with a question, do we want to keep the link or break it? I'll opt to keep the link. I make my changes. Let's call it Top Housing A. Click in an empty area to exit, and let's close the window. You can right-click on the bill of materials. This gives you a drop-down menu with a number of editing and file management options. Let's select Save As. Here we can choose a number of file types, Excel, text files, PDFs, etc., for the export format of the bill of materials. Let's cancel out of this for now. And this concludes our tutorial about the bill of materials in assemblies. Welcome to our second tutorial on the bill of materials in an assembly. First, let's go to Insert, Tables, Bill of Materials. First, we select a table template. We can browse for a file. Under BOM type, let's choose Parts Only. Configurations, I only have one, so that displays here. Part configuration grouping is our next control area. Let me go through these options. Display as one item number. Checking this option lets you use the same item number for different configurations. This first option, Display configurations of the same part as separate items, allows you to list each configuration in the bill of materials if the component has multiple configurations. The next option, Display all configurations of the same part as one item. If you choose this option, when a component has multiple configurations, the components will be listed in one row in the bill of materials. And the third radio button, Display configurations with the same name as one item. If more than one component has the same configuration, they'll be listed in one row in the bill of materials. The next section is where we control item numbers. We choose a start number as well as an increment. Lastly, we have border options. Let's click OK. And here we have our bill of materials. Let's position it somewhere here. To hide or show the bill of materials, you can right-click and select Hide. We can also show a table in a separate window. Oops. Let's try that again. Show Table in New Window. To restore the table to the graphic area, right-click and select Show Table. Now let's insert some balloons. Go to Insert, Annotations, Balloon. And we're going to place them around our assembly. OK. And let's delete this. To hide the balloons, we right-click on Annotations and uncheck Display Annotations. And to bring them back, simply right-click and select Display Annotations. Now let's save our assembly. And let's create a drawing document. OK. B Landscape, OK. Let's drag in an isometric view. Let's use a custom scale of 1:1. Now let's go to Insert, Tables, Bill of Materials. In the BOM Options area, we're able to copy an existing table. From this drop-down menu, we choose the table I just created. We can check here to attach to the anchor point and click OK. Let's expand Sheet Format 1 and reposition the anchor point. Right-click on the Bill of Materials anchor, select Set Anchor, and let's put it right here. Let's go back to our assembly now. Now let's insert a column. Right-click, Insert, Column Right. Let's select Weight as our custom property. And let's reposition the column. We just drag and drop. Now let's save. And let's go back to our drawing document. Let's zoom in a little bit. As you can see, the column on the Bill of Materials table on our drawing document is not updated. The reason for this is that the assembly bill of materials and the drawing bill of materials don't actually link to each other. And this concludes our second tutorial on the bill of materials in an assembly. Welcome to our tutorial about clearance verification. With clearance verification, you can specify the clearance between selected components and the assembly. Let's activate the tool. Go to Tools on the main menu. Clearance verification. The software checks for the minimum distance between the components and reports the clearances that fail to meet the minimum acceptable clearance that you specify. We can select faces, as well as components. Here you specify the numerical value representing the minimum acceptable clearance. Let's click Calculate. Each failed clearance will be listed in the dialog box. You can view each component and its clearance value. When you're finished, click OK. This concludes our tutorial about the clearance verification tool. Welcome to our tutorial about hinge mates. Let's begin by activating the Mates tool. A hinge mate limits the movement between two components to one rotational degree of freedom. It's got the same effect as a combination of a coincident and a concentric mate. Let's scroll down to take a look at our property manager. Under Mechanical Mates, I'm going to select Hinge Mates. First, I select the concentric component, and then I select the coincident component next. Next, we've got the option to specify the angle limit. First, we need to specify the reference faces. The initial angle I'm going to leave at 0. The maximum angle, let's enter a value of 180 degrees. The minimum rotational angle, I'm going to leave at 0 degrees. By the way, the initial angle can't be less than the minimum rotational angle. Keep that in mind. And let's click OK. And here is my hinge. This concludes our tutorial about hinge mates. Welcome to our tutorial about dimension jog. SolidWorks 2009 gives us the ability to jog extension lines. I simply right-click on the extension line and then select Display Options. And from the Display Options submenu, we select Jog. It's actually off the edge of my screen here, but it is down there. All right. Next, grab one of the points and move it. And simply click an empty space to make your change take effect. To remove it, again, right-click, select Display Options again, and unselect Jog. There it is. This concludes our tutorial about dimension jog. Welcome to our tutorial about title blocks. You can now select notes in the title block. In these notes, you can enter text and make modifications right from a drawing. Let's begin by defining a title block. We right-click and select Define Title Block. The rectangle that appears here is our hotspot. I can adjust it as needed by dragging the handles, and I can reposition the rectangle as well. This hotspot rectangle defines the area that users of the drawing can click on to enter data in the title block. Next, we'll select some notes in the title block. These selected notes specify the title block data that users can enter into the drawing or into a drawing created from a template based on this drawing. Here are the arrows that you use to rearrange items in the title block note list. This list that you see here in the Property Manager represents the order which notes are presented to the end user when she tabs through the fields of the title block. We've also got the option to enter text in the tooltip field. Let's click OK when you're finished. Now we go to File, Save As, and let's save it as a drawing template. I'm going to cancel out for now. At this point, we're ready to enter data in the title block. Right-click on the title block and select Enter Title Block Data. Click on the field that you want to edit, and click OK when you're finished. Another way to enter data in the title block is to simply double-click on the hotspot area. Make your changes, and then click OK when you're finished. Again, to edit the title block, right-click on it and select Edit Title Block. And this concludes our tutorial about editing title blocks. Welcome to our tutorial about inserting center marks in slots. SolidWorks 2009 gives us the ability to insert center marks in slots, including the slots in a hole table and display hole callouts for straight holes. Let's begin by going to the File option on the main menu. New. Choose 2D Drawing. OK. Landscape B is just fine for our purposes. Now let's go to Options, Document Properties tab, Detailing, and under Auto Insert on View Creation, check Center Mark Slots. Click OK. Now I'm going to double-click on the Part 33 document. Here we really only need the top view. Let's click and click OK. Let's zoom in a little bit. We now have the slot's center marks automatically inserted. I'm going to drag select and then click Delete. You can also insert the slot center marks manually. Go to Insert, Annotations, Center Mark. Ensure that Slot Center Mark is checked if you want the slot center marks to appear. Make any additional adjustments that you need. And let's cancel out of this for now. There's something else I want to show you. Let's go back to Options. Click on the Document Properties tab and select Center Lines, Center Marks. Let's place the marks at the end of the straight slot. Also, select marks placed at the end of an arced slot and click OK. Let's go back to the Annotation tab. Center Mark. Select a straight slot, the arced slot, and the second arced slot. And click OK. This concludes our tutorial about slot center marks.